Hey everyone, Mr. Mechnick with you today to go through with a setup for the potato osmosis lab. So we're going to be using sweet potatoes for our experiment today. We're going to need a potato corer. I have a glass rod as a push pull, and then I also have a scalpel so we can cut our potato cores. I have 5 different solutions pre-mixed. 0%, which is distilled water, a 5% sugar solution, a 10% sugar solution, 15%, and a 20%. I have 5 test tubes that are cleaned and ready for the addition of the potato and our sugar solution, labeled A, B, C, D, and E, which correspond to 0, 5, 10, 15, and our 20%. We also will need electronic balance to measure our mass cores today, and then we'll come back and measure them tomorrow to see which potato cells absorbed water, which ones lost water, and we will measure the mass change. So here's my potato core. I'm simply going to push a couple potato cores out onto the table. So as I do that, I'm obviously getting 5 different size core samples that we're going to use, and I'll have to cut them up into equal size pieces and get our mass measurements. So I'm gonna pop 5 of these out of here. So here's my glass plunger that I can use to get those out. There's 3. Here's 4. And here is my 5th one. So that one I cut on an angle, so we're gonna cut another one out of here. Again, the size isn't that important. We just need 5 that are close to the same size so we have a good comparison. So I'm gonna take my shortest one. I'm gonna cut the skins off the edges, and we're gonna try to cut them all to that same length. So I used the same size core, potato core for each one of these, so the diameter is the same. Now it's just a matter of getting 5 potato cores that are roughly the same length. So there's 2 pieces. That was cut off the skins of each one. And then we'll end up getting their mass measurements, and that's what you're gonna have to record in your data table. So make sure your data table has enough space to record 5 potato masses for day 1. There's 4, and then I'll cut the skins off of this one. And some years when we do this lab, we use regular potatoes. This year I decided to use sweet potatoes. So our goal, again, is to determine how much sugar content is in these potatoes. So one nice thing about sweet potatoes, they're not as starchy as regular potatoes. I'm just gonna dry them as much as I can to make sure we don't have any excess water that's leaking out from all the damage that took place when I cut those. And so now I have my 5 samples, and just to keep them organized, I'm gonna label on my piece of paper A, B, C, D, and E, so I don't get any of these mixed up. And what we need to do next is get our mass measurements recorded. So to do your mass measurement, I'm going to add a piece of paper onto my balance so I don't get any of the residue from the potato cores onto my balance. I'm going to hit the 0 button, so I'm going to tear my balance, and now I'm going to get my mass measurements. So hopefully you can see the numbers on here, but the first one for letter A, 1.54 grams. So you need to make sure that that is recorded. I'll just write it down right here, 1.54 grams. That is letter B. Or here's letter B, which is the 5%. So this is 1.66 grams. Sample C, 1.56. I'm writing these down so you can see them and you can easily get them recorded into your data table. 1.49 grams. And then my last one, 1.53 grams. So not too bad. They were all roughly about 1.5 grams. So now the next step is to place them into test tubes with some of our solutions that are pre-mixed. So I'm going to put the A sample in test tube A, B in B, C in C, D, and E. So now, sample A, we're just going to pipette some of the 0% sugar solution into the test tube. It doesn't matter how much, just enough to make sure that they're completely submerged. You can see that they're sort of floating, but as it starts to either absorb or lose water, we have enough of the cells that are exposed. So I will pipette the 5% into test tube letter B. So I'm just going to do 10 milliliters in each one. Again, the amount doesn't matter just as long as they are fully covered. So there's 10 milliliters, which letter C has the 10%. So this is 10% sugar. Test tube D, as in dog, has the 15% sugar. And letter E will contain the 20%. All right, so just to review, our A is 0% sugar, our B is 5% sugar, C is 10%, D is 15%, and the sample that's in test tube E is a 20% sugar. So tomorrow, we are going to come back and we are going to record the masses for day 2. So over the next 24 hours, osmosis should happen, meaning water will either enter or exit the cells of the sweet potato. And by doing this, we should be able to determine the concentration of sugar in a potato cell. Thanks for joining me. That's all you guys need to do for today.